BSc Calculus students, in this video I'm going to explain what is the polar coordinate system and what are the graphs, how do the graph looks like, and what are the coordinates. So this is a review of pre-calculus. So understand the polar coordinate system. We do not have to rewrite the equations, but you must understand the connections between the rectangular equations, which is in xy terms, and the polar equations. You must know what the polar graph looks like and the points of intersection, how to find where the two graphs intersects. So this is in your packet. Let's take a look at polar coordinates. So polar coordinates system is a polar graph, and polar graph has a radius and the angle. So this is in your packet, and you can see the coordinates, polar coordinates are written as r and theta, and the rectangular coordinates are x and y. You have to understand the relationship between x, y, and r theta. So for that part, let's take a look at the unit circle piece. I explained this is everything is coming straight from the unit circle. So this is the r, this is angle theta, this is x, and this is a y. So if you write sine theta is y over r. So you can say y is equal to r times sine theta, which is this equation. If you write cosine theta is x over r, and you can say x is equal to r cosine theta. So these two equations are very important. You must know in calculus how to convert r and theta to x and y. And in calculus, you will have to find the slope and derivative dy dx, but you are given r and theta, so you will have to change to x and y, and then only you can find the slope. So this is a very simple connections from the unit circle, which is x, y, r theta, and you may recall that sine theta is y over r, cosine theta x over r, and x and y in terms of r and theta. Equation of the circle is x square plus y square is equal to r square, the radius square, and tangent theta is always y over x. So if you have to find the angle theta, then you can say tangent inverse y over x. Now another thing you have to understand about the polar coordinates is radius could be negative. How radius is negative? When radius is negative, that means angle is in opposite direction. So this is the r and that's the theta. If it is a negative radius, then instead of pi over 2, you go in the opposite direction. So multiple representation, one point can be written so many different ways. This point I can also say this is radius is 3 and the angle is 3 pi over 2. You can also say that radius is negative 3 and angle is pi over 2. You can also say radius is a 3 and you can make one more round, 2 pi plus 3 pi over 2. So one point can have so many different ways you can write the coordinates. Just understand the negative radius means you go in the opposite direction. So in your packet, you have some examples. You don't have to do all of them. We are just reviewing. Again, x is a r cosine theta, y is a r sine theta. Everything is coming from straight from the unit circle. This is r, that's angle theta. This is y and x. One triangle will give you all this information. So you don't have to do all of this, just one of them. Convert from polar coordinates to rectangular coordinates. So let's take a look at the easiest one here. You will not be asked this kind of question. We are just trying to understand what's the location of this. So negative pi over 2 is here, but negative radius send it back here. So I can say that in rectangular coordinates, x is a 0 and y is a 2. This is x and y. So location is very important. 2 pi over 3 is here, radius is a 6. So what will be your x and y? X is a 6 cosine 2 pi over 3 and y will be 6 sine 2 pi over 3. You will need to know the unit circle angles to change to rectangular coordinates. Let's take a look at one more here, 5 and negative 5. This is x and y. You need r and theta. So x is a 5, y is negative 5. Here you can see that the both numbers are same. That means angle is 45. And the radius will be 5 root 2, x square plus y square, radius square, 5 root 2. And the angle is 7 pi over 4 because that's in a fourth quadrant. Let's take a look at equation conversion. Equation conversions rarely being used in the calculus, so I'm not going over there. What you have to know for pre-calculus point of view is the intersection. Where do the two graphs intersect each other? 5 cosine 2 theta is 4 petal rows. Let me bring it back. This is the 4 petal rows and radius is a 5. So you will have to find where the graph crosses each other. I will explain more this in the class, but for now I believe you should know the shape of the graphs. So this is the Lee-Masson. You can put in a calculator and try to sketch different graphs and see how they look like. The most important one is the rose petal. This one. This is a 3 petal rows. Check in the calculator, r is equal to 2 cosine 3 theta. Check what kind of graph do you get. You will see very similar 3 pattern graph. Length of the petal will be 2. If n is an odd number, you get double the amount of petals. Try again in a calculator. I'm going to show you in a minute. Is 3 cosine 4 theta, you will have 8 petals. So rose is, how do we get the petals, which I'm going to explain in a minute. Let's talk about the circle. Circle is, know that circle, how this circle becomes. The construction of the graphs you must understand. So let me explain one of them. Let's say in a rectangular mode, you graph 2 cosine x. So 2 cosine x is a cosine, no, sorry, that's a sine graph. Let me try, start over. Okay. 2 cosine x, that's the cosine graph. What happened is, you have to know where the graph crosses. So construction of the circle is when x is a 0, radius is 1. So this is your beginning. Then this is pi over 2, the radius is 0, so that's a pi over 2. So this is 0, radius is pi over 2, and angle is pi over 2, radius is a 0. So that's my polar coordinate 0. Then back here is back here at the pi. So this half the circle gives you, half the loop gives you one circle. It would be much easier to understand from the sine graph. Let's take a look at the sine graph. Sine graph 0, 0. Then this is also 0, so that make a round and 0. So between 0 and 2 pi, circle is making 2 rounds. This is 0, back to pi, and back to 2 pi. So in one circle, it looks like this is a 0 to 2 pi, but this one circle completes in 0 to pi. I'm going to show you in the calculator as well. So first, let me go on this page where you have in your packet, find out this page in your packet. And I'm going to show you in the calculator and without calculator. So what we have to understand is how long it takes to complete one petal. You will be asked to find the area of the petal. You can use calculator to find the area, but many times you have to do the setup. So what's the pattern here? 3 cosine 2 theta is equal to 0. Put the radius is 0. So how many times you come back from here, center to here, from here to here? So let's say take a look at here, 3 cosine 2 theta equal to 0. This is the reason you learn how to solve trig equations in pre-calculus. So I can say cosine 2 theta is equal to 0. Cosine is 0 at pi over 2, 3 pi over 2. Since this is a double angle, you have to make one more round, which will be 5 pi over 2 and 7 pi over 2. So theta is pi over, divide by 2 is pi over 4, 3 pi over 4, 5 pi over 4 and 7 pi over 4. What this means is radius will be 0. That means you are at the pole. When angle is all these 4 angles, radius will be 0. So to pick one petal, you have to use any 2 consecutive zeros, pi over 4 to 3 pi over 4, or 3 pi over 4 to 5 pi over 4, or these 2, and after 7 pi over 4, it will be, next round will be another pi over 4, which will be 9 pi over 4. So this pattern will be between 5 pi over 4 and 7 pi over 4. It would be again easier if you make a table. This is r and this is theta. Radius will be 0 when angle is pi over 4. When angle is 0, radius will be 3. So this is a 0. Then you go in pi over 4. Then you go here. You have to understand the construction of the circle. So watch how it will be going. It starts from here, then it will go this side. You have to know the path of the circle, and then it's come back. So you start from here, you go in, then you go this way, going back up. So let's take a look at the calculator. It's much easier to again put in the calculator. So go in the mode, change the mode into parapolar. Sorry, I'm going back. Polar mode, and put in the equation 3 cosine 2 theta, and then graph. Now of course I have to set the window again. It is 0 to 2 pi x minimum. Don't worry, let's try zoom 7. You should see that if you press zoom 7. And now let's press the trace button. You can see the graph starts from here. Trace the graph and check the path of the graph. That means where the graph is going. Look at the cursor, and you need to know the construction of the graph, how the 4 petal rose is being constructed. So again, 2 theta means 4 petals, and you will be asked to find area of 1 petal. If you have to find area of 1 petal, you can easily say 0 to 2 pi and divide by 4. But that's not the case. Sometimes you will be asked to find the area of the inner loop, which is inside here. What will be the angle which defines this loop? You just want to find this loop, that's all. Know that polar graphs always sweep from inside. The radius is starting from inside. So again, need to know how to solve this trig equation. Set it equal to 0. Solve for angle. Cosine is negative in to this 2 quadrant, which will be 4 pi over 3 and 5 pi over 3, which means this inner loop defines the angle between these two. Inner loop defines angle between these two. So starting from 0, if you want, you can again make the table theta and r. When theta is a 0, radius will be 3, because cosine is a 0, 2 plus 1 is a 3. When it's a pi over 2, or whichever one you want, you can see what will be the radius. So between these two, the loop will be between 4 pi over 3 and 5 pi over 3. Very interesting one is the 3-petal rose. So let's talk about the 3-petal rose. 3-petal rose. I'm going to make a connection way back in pre-calculus. Y is equal to 2 sine 3 theta. You have to understand the connection between rectangular and polar. What's the period? Period will be 2 pi over 3. So if I look at this is 2 pi and one circle is being completed, one loop is completed in 2 pi over 3. In pre-calculus, we learn x, let's say 2 sine 3x. B is a 3. Period is 2 pi over b, which is 2 pi over 3. If period is 2 pi over 3, which means the sine graph completes one loop in 2 pi over 3, the radius, the magnitude, the amplitude is a 2. Okay, how this graph becomes the polar graph, we are going to see in a minute. But then each time you see one more round and one more round. So you see the 3 petals. In fact, there are 6 petals, 0 to 2 pi. So if you make a loop, let's start, let's show you again 2 sine 3 theta. Solve for theta. And you will have sine is 0. So 3 theta, sine will be 0 at 0 and pi. Since this is a triple angle, you have to make 3 rounds. You can see that 1, 2, and 3. So 0 to pi, 2 pi, 3 pi, 4 pi, and 5 pi. This is 1 round, 2 round, 3 round. And if you solve for theta, 0, pi over 3, 2 pi over 3, 3 pi divided by 3 is a pi, 4 pi over 3, and 5 pi over 3. So let's check it out. 0 is, you start at 0, 0 is 0. 1 round, pi over 3, you are back in the middle. Then again, you are back in the middle, 2 pi over 3 to 3, and then you are back in the middle. So between 0 and pi, you are already making 3 petals. You can see that from here, petal number 1, 2, 3. 1, 2, 3. Then between pi and back here it will be 2 pi. 0 is same as 2 pi. This will give you another 3 petals. 3 petal rose is the only special one. You see 3 petals, but actually there are 6 of them. Where those 6 comes here, which is here, 4, 5, and 6. Between 0 and 2 pi, 3 petal rose is making 2 rounds. It's making 2 rounds. If you have to find area of one petal, make sure you can do it 0 to 2 pi divide by 6. Or you can make it 0 to pi divide by 3. 3 petal rose is the only special one where you have to know that where those 3 petals coming from. 1, 2, 3, 4, 5, 6, because the period is 2 pi over 3. That means you get 2 rounds, and then exactly this is what the petals is. This is from 0 to pi over 3. You get 1 petal. Pi over 3 to 2 pi over 3. That's my petal number 2. Then back to here, 3. This is a pi. You get the 3rd petal, and then this is another 3 petals. So 3 on top of the other 3. Again, you can put in a calculator and let's check it out. Let's check this. 2 sine 3 theta. That's a graph. Okay, so you can make it a zoom 4 to see the bigger one. I guess it doesn't work. Doesn't matter. Let's see here. It works. So let's start from 0. You can see theta is a 0. Now start tracing. And keep an eye on the angle theta. Now this will be in a radian. You have to do in a radian. So watch the watch the path of the, look at the tracer and then see how it's going. And you can see that 314 is 3.2 is 1 pi, and in 1 pi you already made three loops. 3 petals are already completed in 1 pi, and then you continue tracing and you will see there are another 3 petals, which is the same case as circle also. So let's talk about the circle. 2, I'm going to clear it and show you how the circle is also making 2 rounds. 2 sine theta. Let's check it out, the circle. How does the circle look like? Now let's press trace button. 0, that will be pi over 2, because sine pi over 2, that's a 1.57 is a pi over 2, and that will be your one circle. See, in a pi, 0 to pi, 3.114 theta is, you already made a one circle. So circle makes 2 rounds from 0 to 2 pi. Same thing, 3 petal rows makes a 6 rounds. Play around with calculator, know how to graph on a polar mode and rectangular mode, and we will talk about how we apply this in a calculus in class. Thank you.